Hello everyone, I want to talk to you about U substitutions. This is what I mean, U substitution. Okay, so you're going to start seeing antiderivatives that look like this, and it may be rather complicated to take the antiderivative at this stage unless you were to multiply this out 7 times and then multiply it by 4x, but that would be time consuming. So we're going to look for another way to do it. Now with U substitution, it might be that we can change the appearance of this antiderivative if we can change chunks of information so that they have U's in them instead of X's. So let me show you what I mean. All right, so you always want to look at a problem and see if you can pick a U such that its derivative is also in the problem. So I'm going to let my U equal 2x squared plus 1, which is right there. Because if I take the derivative of U, then that is 4x dx, right? So you have to always, with the U substitution, you always have to acknowledge that you took the derivative with respect to x. X was your changing variable. So you notice there's this piece right there. There's the du piece. Okay, so I'll say it again. You always pick your U such that its derivative is also in your antiderivative. Both have to be in your antiderivative. All right, so what that does is it allows me to rewrite the integral of 2x squared plus 1 to the 7th power times 4x dx as the integral of u to the 7th. Notice there's my u. And this piece, all of this, represents my du. All right, so now this is something that I could do. If this said x to the 7th dx, I should be able to take the antiderivative. So if it says u to the 7th du, we should be able to take the antiderivative as well. So what are we going to do? The antiderivative of the power rule. U to the 8th, add 1 to the power, divide by the new power, plus c. Right? So all I have left to do now that I'm outside of the antiderivative, notice this notation is no longer necessary because I did what it told me to do. It said add 1 to this power and then divide by the power. Notice it does not stay. It goes away because I've done what it told me to do. The last thing that you want to do is to go back and make your substitution. Okay, so your final answer should be 2x squared plus 1 to the 8th power all over 8 plus c. And that's it, right? So you'll notice what's occurring is I started off with x's. It ended up being too complicated. I converted everything to u's. I made my antiderivative, and then I went back to the x's. All right, let's try another one. What about this one? Okay, this looks rather complicated. It says x squared times 2x cubed plus 3 to the 4th power. Okay, I don't want to multiply everything out, so instead I'll create a u. So u equals, I'm going to let this equal my u, see what happens. 2x cubed plus 3. So my u is this chunk of information. So then the derivative of my u, that's what the d means, derivative, is, well, the derivative of 2x cubed is 6x squared, and the derivative of 3 is 0, and that is with respect to x. Okay, so we took the derivative of u, and over here we have to acknowledge that we took the derivative with respect to x. Okay, so let's go over here and see if we can simplify this. You'll notice that the thing that's missing here is the 6. There are a variety of ways, the thing that's missing here is the 6. There are a variety of ways of addressing that. So what I really would like to have is just the x squared and the dx. So why don't I just divide both sides by 6? Divide this side by 6, divide this side by 6, and I get du over 6 equals the x squared dx that I already have in my problem. So to be clear, there it is. Here's the x squared right here, and there's the dx. Okay, if that makes you uncomfortable, then I'll just shift these around so that you can see them next to each other. So the integral of 2x squared, or cubed rather, plus 3 to the 4th power. I'm going to shift this to the end. So times x squared dx. Right? So at this stage, all I've done is just move some things around. That's it. So now when I do my u substitution, I have the integral of, okay, if you look closely, there's my u right there. U to the 4th. And then there's this piece right here. Times du over 6. Look closely. There's x squared dx. And then we have du over 6. So what does that mean? It means that we should be able to pull out the 1/6. Notice there's an invisible 1 that's multiplied by everything in the numerator. 1/6. The integral of u to the 4th du. And let's have at it. So this equals 1 over 6 u to the 4 plus 1 divided by 4 plus 1 plus c. Which equals 1/6 u to the 5th over 5 plus c. Okay, give me a second, I'll get some more paper. So this equals u to the 5th over 30 plus c. So we got to be really careful because we want to be able to go back and make our substitution. So let's see if I can get this in the same frame. Look, there's my u, right? So all I'm going to do is take this 2x cubed plus 3 and plug it right there for the u. So then my final answer should look like this. 2x cubed plus 3 to the 5th power, all over 30, plus c. And you're done. Okay? So let's try another. What if you were presented with this problem, right? So this is a little different than the shortcut that I showed you. Definitely doable. Well, you can see that. E to the 2t plus 3. All right. So, a little hard to see. Okay, by the way, these problems, many of them are in your notes already. So what I'm going to do is I'll let u equal 2t plus 3. Okay? So then my du equals 2. The derivative of 2t is 2. Derivative of 3 is 0. And then we have to acknowledge dt. Now, one of the things that you have to keep in mind is that the numbers don't matter. You just have to have the variables 100% correct, not the numbers. Okay, so I want to show you the one that I just did, this one here. Notice x squared dx, and then when I went over here and took my derivative, I actually got 6x squared dx, and I found a way around not having the 6, right? So I'm going to do the same thing here, because if you'll look, the only thing you have is the dt. You don't have the 2, right? That's of no consequence. We shouldn't have to worry about that. So what I'm going to do is I'm going to divide both sides here by 2. And what does that give me? dt equals du over 2. All right, so let's go over here, see if I can simplify this. So this is the antiderivative of e to the u. Notice that's what I chose for my u. And then where my dt is, I'm going to put du over 2. All right, so as I mentioned in the last one, there's an invisible 1 on the top, so we can pull out 1 over 2. This is the antiderivative of e to u du. Now this is one I asked you guys to memorize. There is an invisible 1 right here. So the shortcut for this, 1 over 2, pull that out. It's 1 over whatever the coefficient is of your variable, 1 over 1. And then you copy down what this function is, e to u plus c. And you're done, right? So we're tying in a shortcut that we had from earlier. So this is 1 over 2 e to the, we got to go back to what we labeled as our u, which is 2t plus 3 plus c. And that's all of that.